Hello and welcome back to the channel. Today we find the answer to the question that daunted in my head for some time now. How does memory performance affect gaming workloads? Now, RAM, or Random Access Memory, is the star of the show, and with the surge of Ryzen in the last years, it looks like memory speed has started to matter a lot more. But how does that look if you have a CPU bound scenario? Meet the i5-2500K, a CPU from the last decade, almost equivalent to a Ryzen 3 2200G, when overclocked to 4.2 GHz. Paired to it will have 16 GB of Kingston HyperX DDR3, which will clock to a different speed starting from 1066 MHz all the way up to 2133. So more than a gigahertz higher, we're at a fixed CAS of 91111. Okay, let's get into the benchmarks and later we will discuss the numbers. So, as you can see, we have a degree of scaling in both Shadow of the Tomb Raider and in the Division, although we can see that in the Division we are hitting a hard GPU bottleneck shown in the upwards of 95% average GPU usage. Looking at the data, here we have a good improvement from 1066 MHz to 1343, showing that 1066 MHz is a little too slow for standard bridge architecture. At 1066 MHz we see the worst results in both games, and here the CPU bottlenecks the graphics card pretty hard. But the most in the newer title. Going up to 1343 MHz, we see some improvement of about 7 percentage points, getting to a 60 FPS average in Shadow of the Tomb Raider. In the Division, we get to see the first main GPU bottleneck, with 92% usage showing that this Ubisoft game is more GPU heavy. Raising the speed to 1600 MHz, half a gigahertz from the original speed, we see a relatively incremental increase in performance, where in the 2018 Tomb Raider we have 4% increase in average numbers and a 14% increase in GPU usage, or to be more precise, the lack of CPU bottlenecking. In the other title we have too little of a difference, but we can still see some GPU usage and less CPU usage. Now we get into the interesting results. At 1866 MHz we still see scaling somewhat, showing that the CPU can push more frames. In the Division we are almost completely saturated with the GPU, and scaling is measured in points of percentage. And we conclude that the max speed that these RAM chips can do with the CAS set to 9, which is 2143 MHz. The starting speed for DDR4, this was the speed that high-end chips were targeting back in 2011. Here we see a fall in efficiency, as the improvement is only 3% for an increase of almost 20% in voltage and power consumption. Here quickly we can see a graph of efficiency, or more exactly performance increase for the same wattage. As it looks, no speed is good for efficiency if you start from 1066 MHz, but for example, my set of RAM is rated for 1866 MHz of a CAS of 11 at 1.5 volts, and if you just reduce the CAS to say 9 and add a little bit of voltage, that can go a long way. So at the end of the day, there you have it, the impact of memory speed on gaming for an old Intel chip. Now, this data can be extrapolated for newer Intel chips somewhat, but for Ryzen certainly not, as that silicon you have to keep in mind the Infinity Fabric speed, which is directly linked to the memory speed. That was all for now. If you liked the video, make sure to hit the like button and get subscribed for more. I am Hardware Shenanigans. Have a great day.